A farmer gets offered a check to lease his land to a solar company. Good deal. Except he loses his farm. That is the deal being offered right now, everywhere. Most farmers say no. The ones who say yes often regret it, and solar developers spend years fighting that resistance. Lawyers, negotiations, zoning battles, political opposition. There is a version of this deal where the farmer gets the check and keeps the farm. Same land, same solar panels. One simple change: raise the panels off the ground. Elevated solar panels create a canopy. Underneath that canopy, you can grow food, medicinal plants, and in degraded land, you can restore the soil itself. Energy and agriculture simultaneously. Studies consistently show crops like lettuce, berries, and root vegetables grow better under partial shade. Water demand drops by up to 50%. In dry climates, that is the difference between viable and not viable. The farmer now has two income streams on the same land. Lease income from the solar developer. Agricultural income from what grows underneath. No forced choice. No lost asset. For the solar industry, this is not just a nice idea. It dissolves the single most expensive friction in their entire business model. Land acquisition. Community resistance. Agricultural lobby opposition. Gone. The additional cost of elevated mounting is not a cost. It is the price of eliminating years of negotiation, legal battles, and failed projects. The math works in the industry's favor. Now scale that logic to the places that need it most. The Sahara, the Sahel. The African Great Green Wall Project, stretching from Senegal to Djibouti, is planting trees to stop desertification. The results are mixed. Monoculture planting in degraded arid soil has significant failure rates. The trees die because the soil is too compacted, too dry, too depleted to support them. Elevated solar above pioneer tree species changes that equation entirely. The canopy reduces surface temperature. It cuts soil evaporation dramatically. It gives seedlings the shade they need to survive establishment. Hemp planted underneath breaks compacted soil with a 2-meter taproot. It returns organic matter fast. It needs almost no water once established. It prepares the ground for everything that comes after. The trees that follow do something remarkable. Deep-rooted native species pull groundwater up through a process called hydraulic lift. They strip moisture from fog. They restore the water cycle from below and above simultaneously. In Borneo, a conservationist named Willie Smits demonstrated this. He planted the right succession of species in the right sequence. Degraded land began producing surface water flows. Streams formed where there were none. This is not magic. It is sequencing. Pioneer species first. Soil restoration second. Climax native forest third. Each stage creates conditions the next stage requires. The solar canopy makes stage 1 survivable. Now, China. The Gobi Desert is expanding. Sandstorms bury Beijing. Agricultural land is being swallowed. China has been running the 3 North Shelter Forest program since 1978 to stop it. China has the largest solar manufacturing capacity on Earth, the largest installation rate, the engineering capacity to mobilize at any scale, and an existential crisis that elevated agrivoltaic restoration would directly solve. The anomaly is that these two programs, solar and reforestation, have never been formally combined in the 3 North Zone at scale. The solution to both problems is the same infrastructure. Now Anatolia, modern Turkey. The landscape there was densely forested in antiquity. Roman bathhouses required industrial quantities of wood fuel continuously. Hundreds of bathhouses across centuries stripped the watershed bare. The Romans recorded their engineering achievements, the bathhouses, the aqueducts, the civic monuments. They did not record the deforestation. That record is written in the soil and the hydrology instead. Turkey has been running one of the largest tree planting programs in the world. The question is not whether they are planting. The question is what they are planting and in what sequence. Native species whose root systems already have a relationship with Anatolian soil are the foundation. Oriental beech, Caucasian alder, properly mixed native pine. Elevated solar above them during establishment changes the survival equation. Restored Anatolian watersheds produce agricultural land, stable water supply, and if elevated solar is the canopy, energy simultaneously. The Roman extraction runs in reverse. The compounding loop works in both directions. Ground-mounted solar was designed by energy engineers solving an energy problem. Nobody at the table was asking what happens to the land underneath for the next 30 years. That is not a conspiracy. It is a design oversight that got standardized before anyone measured the full cost. And standardized assumptions are the hardest things to change, not because they are right, but because they are familiar. The farmer gets 2 paychecks. The solar developer gets the land. The desert gets a fighting chance. The watershed begins to recover. All from one design decision. Raise the panels off the ground. We said, stop treating land as a single-use surface. Raise the solar panels. Keep the farm. Restore the land. Produce the energy. Same footprint, multiple outputs. Once again, the same philosophy running in the opposite direction. If solar was about what we build above ground, this is about what we refuse to build below it. Data centers are the physical backbone of the internet. Every search, every stream, every transaction, every AI query runs through one. And right now, almost all of them sit on the surface of the earth. They consume land. They consume enormous amounts of water for cooling, and they consume roughly the same amount of energy managing their own heat as they do actually running their operations. That last number is worth sitting with. Approximately 40% of a data center's total energy consumption goes toward cooling. Not computing, not storage, not connectivity, just managing the heat the building generates. That is not a small inefficiency. That is nearly half the energy bill of one of the fastest growing infrastructure categories on Earth doing nothing except keeping the facility from destroying itself. Now go underground. 10 to 15 meters below the surface, ambient ground temperature stabilizes at between 10 and 15 degrees Celsius, globally. Regardless of whether you are in Norway or Nigeria, that stable cool temperature is not a geological accident. It is a free cooling resource that exists everywhere on Earth, continuously, without any energy input whatsoever. It has never been systematically used for data infrastructure. Underground ambient temperature alone does not solve the full cooling problem at scale. Concentrated server heat is intense enough to require active airflow. This is where the design gets genuinely elegant. Build a wind tunnel into the underground structure. The natural pressure differential between underground air and surface air creates continuous airflow through the facility. That airflow carries heat out passively. No mechanical chillers, no cooling towers, no water consumption for evaporative cooling, no additional energy load managing heat. The geology and the physics do the work. The engineering just needs to stop ignoring them. What does eliminating 40% of energy consumption do for a data center operator? It changes the entire economic model. Smaller energy contracts, smaller carbon footprint, smaller operating cost, permanently for the life of the facility. It also changes the siting logic entirely. Currently, data centers cluster near cheap energy sources and cold climates because both reduce cooling costs. Underground facilities with wind tunnel design can go anywhere there is bedrock. That matters for the regions currently excluded from data infrastructure. Large parts of Africa, Central Asia, and South America have geology perfectly suited for underground data centers and almost no local data infrastructure above ground. Now add the closed loop. Remember the elevated solar canopy. Raise the panels above ground. Farm underneath. Restore degraded soil. The solar feeds whatever is connected to it. Put the underground data center directly below the elevated solar installation. The panels above generate energy. The facility below consumes it. The cooling is handled by the ground and the wind tunnel passively. You have just built a largely self-contained energy and compute installation on a single surface footprint. The land above is still usable. The energy is generated on site. The cooling costs almost nothing. The surface land remains productive. The subsurface becomes productive. The solar output goes further because the facility it feeds needs dramatically less energy for cooling. Every element amplifies the others. This is the same design logic as part 1. Stop treating any layer of the available environment as single-use or wasted space. Above ground, surface, and subsurface are three separate productive layers on the same footprint. So why aren't data centers being built underground? The answers follow a familiar pattern. The people with capital to build them were trained on surface construction. Surface construction is what financing models are built around. Underground construction has higher upfront engineering costs, and the organizations making siting decisions are optimizing for speed of deployment, not lifetime operating efficiency. The 40% cooling cost is baked in as normal. Normal is the most powerful force in infrastructure development, not physics, not economics, not engineering possibility. What was done before is what gets done again, until the need for an alternative becomes impossible to ignore. The cooling industry serving data centers is substantial. Chillers, cooling towers, cooling management systems, cooling energy contracts. That 40% is not just a cost to the data center operator, it is revenue to someone else. Judge by fruits. The current design produces a permanent cooling cost, a permanent energy premium, a permanent water consumption load, and a permanent constraint on where data infrastructure can viably be built. The underground wind tunnel design eliminates most of that permanently. The fruits of that design serve the operator, the grid, the local water supply, and the regions currently excluded from data infrastructure simultaneously. First we said, raise the panels off the ground. Now we say, put the data center under it. Same philosophy, same logic. One design decision changes what the entire footprint produces. Above the surface, elevated solar and productive land simultaneously. Below the surface, data infrastructure cooled by geology and wind. Between them, a closed energy loop that makes both more efficient than either would be alone. The technology exists. The geology exists everywhere. The engineering is not speculative. The economic case is stronger than the current model when measured across the lifetime of the facility. The only thing that doesn't exist yet is the decision to treat above ground and below ground as part of the same design problem instead of two separate industries that never talk to each other. That is not a technical failure. That is an imagination failure. And imagination failures are the ones that are hardest to forgive. In 1937, the United States government made hemp illegal. Not because it was dangerous, because someone needed it to be illegal. That someone owned timber forests and paper mills. William Randolph Hearst had a problem. Hemp paper was cheaper to produce, required less processing, and didn't need the same chemical bleaching as timber paper. It was a direct threat to his entire business model. He couldn't outcompete hemp on merit, so he didn't try. He used his newspapers to run a moral panic campaign. Reefer madness. Public health. The children. The Marijuana Tax Act passed in 1937. The legislation never mentioned paper once. It didn't need to. The competitor was eliminated under a completely different framing. The inferior product was protected. The extraction model was secured. The system worked perfectly. This is not ancient history. This is the operating manual. And once you see the mechanism, you start finding it everywhere. Find a road built in the Robert Moses era, mid-20th century, some of them pushing 80 years old. Now, find a road resurfaced 5 years ago. Compare the potholes. The engineering knowledge didn't disappear. The materials didn't become unavailable. The capability to build durable road infrastructure is the same. What changed was the incentive structure measuring success. Moses-era roads were public works prestige projects. The measurement of success was longevity and civic achievement. Engineers built monuments. Their reputation was attached to the durability of what they built. Current road procurement is a contract cycle. The measurement of success is budget compliance this fiscal year. The lowest bid wins. The resurfacing contract comes around again in 7 years. The books balance. The pothole is not an engineering failure. It is an accounting success. The inferior recurring product beats the superior permanent solution every time the incentive structure rewards extraction over output. Now go to your kitchen. Think about the oldest appliance you know of still running. A 1940s refrigerator in someone's garage. A 1965 washing machine that outlasted 3 replacements. Cast iron cookware passed down as inheritance. Those machines were designed by engineers whose measurement of success was simple. Does it work? Can it be fixed when it doesn't? Standardized parts, simple mechanical components. A repairman could diagnose it with his eyes. The modern refrigerator has a circuit board controlling the compressor that costs more to replace than the fridge is worth. Proprietary refrigerant requiring a certified technician. Sealed units with no user-serviceable parts inside. Every one of those design decisions required an active choice by an engineer who knew the alternative. This is not planned obsolescence. It is designed irreparability. The failure mode is engineered in deliberately. 3 examples, 3 different scales. Legislative capture eliminating a superior competitor. Procurement cycles rewarding inferior recurring contracts. Consumer products engineered to fail and be replaced. The system is not broken. A broken system produces these outcomes by accident. This system produces them consistently, across industries, across decades, across continents. That is not malfunction. That is function. The civic prestige mentality that built Moses-era roads, that demanded durable goods, that measured success by longevity and community benefit. That mentality was the natural check on this mechanism. It had to go. A population measuring infrastructure by longevity notices when roads deteriorate faster than they should. Asks why. Demands accountability. That population is resistant to extraction dressed as normal. A population measuring infrastructure by whether the project completed on budget this fiscal year accepts deterioration as inevitable, accepts designed irreparability as progress, accepts the resurfacing contract as necessary. That population is not resistant. Accepting deterioration as inevitable is the consent that was manufactured, not through conspiracy, through 1,000 small institutional decisions that each made individual sense and collectively hollowed out the mentality that would have resisted. So the question becomes, has anyone ever designed a system specifically to prevent this mechanism? Built institutions whose explicit purpose was keeping profit connected to value actually delivered? The answer is yes, and it ran at civilizational scale for centuries. It didn't require perfect human beings. It required the right institutional design applied consistently. In the classical Islamic marketplace, there was an institution called the Muhtasib, a market inspector whose explicit function was walking the bazaar, checking weights, quality, and pricing. Not to eliminate profit, to ensure profit remained proportional to value delivered. The Muhtasib's own reputation was attached to the quality of the market he supervised. Legacy accountability built directly into the institutional design. The same mentality that built Moses-era roads, formalized as a civic institution. The prohibition on riba, usually translated as interest, targeted something precise. Money making money without productive activity. Profit disconnected from value created. The extraction mechanism named and structurally prohibited. This is not a religious argument. It is a systems design observation. Someone identified the exact mechanism that produces hemp prohibition, pothole procurement, and designed irreparability. Then built institutions specifically engineered to prevent it. You don't have to adopt anything. You don't have to change your beliefs. You just have to ask one question. Should there be any relationship between how much profit you make and how much value you actually created? Most people across every culture and political orientation answer yes instinctively. The system we described answers no structurally. The prototype we just outlined answered yes institutionally and ran that answer at scale for centuries. Parts 1 and 2 of this series asked why aren't they building elevated solar above farmland and data centers below ground? The elegant solutions exist. The engineering works. The economics are favorable. The answer is the same answer every time. The elegant solution terminates the extraction model built around the inferior one. The system isn't failing to find better solutions. It's succeeding at protecting worse ones. The system isn't broken. It's captured. And the first step to building something better is understanding precisely what captured it and what a system designed to resist that capture actually looked like. We stopped teaching that. This is what they don't teach.